Everyone, today in this video we're gonna discuss another topic of uniform circular motion, which is velocity. Okay, so first of all we will discuss the velocity in the uniform circular motion. So for that we will make one circle, and as I said, in the circle we have diameter which will show the shadow of SHM, simple harmonic motion. Now here we have one point, okay, and this is the shadow of that point represented by Q. If you haven't watched the previous video, kindly go and watch. And this is the, we can say, radius. And here we have mean position. Fine, this is the radius. Now here you might know that we have to know that velocity in the circular motion is always tangent. Okay, तो जहाँ पर ये सर्कल मूव करेगा velocity will be tangent to that, मतलब उस सर्कल के स्ट्रेट होगी. तो सर्कल is moving like this, तो velocity will be like this, tangent velocity. So now you might know that whenever we are you going with the tangent velocity, we must have, we can say, mm, we must have the component of that, and we learn component in chapter vectors. Okay, so here you have look into it. So here the component will be 1, another component will be like this. These are the two component of this tangential velocity. So here this component is making angle with this, when that is VP, tangential velocity, and this is the VPX component, and this is VPY component. Why I denote this VPX component? Because remember, whenever the line from which the angle is being formed, that line is named as x component. So here we have tangential velocity x component, tangential velocity y component. Okay, and this is tangential velocity q. Now here you have to find out what you have to find out, velocity. So here the particle की velocity y point is parallel to the velocity of a shadow. Okay, now here we will take the point y for this, we can say, tangential velocity. Why? Because here the y component of this tangential velocity is parallel to the, we can say, shadow of the SHM. So the one component which is parallel to the shadow of HSM, we will take that component as a tangential velocity. So here we have VQ, which is a shadow of the SHM, will be equal to the y component of tangential velocity, which is VP y component. Okay, and here you know that we can say x component is represented by cos theta. However, y component is represented by sin theta. So here we'll put sin theta. It will be VQ, which is shadow of the, we can say, SHM, will be equal to VP sin theta. Okay, after that, here we know that as in the previous video we have learned, if you haven't watched, go and watch. Tangential velocity will be equal to r omega. VP tangential velocity is equal to r omega. This is what we have learned in the circular motion video, angular velocity. Okay, and since here we know that here sin theta, so sin theta is equal to what? Sin theta is equal to 1 minus cos theta. Minus cos is theta करोगे to be radical. 1 minus cos square theta is equal to sin theta. So just put up the values of the sin theta in the equation. First we can say denote VP as a RW. That will be VQ, velocity of a shadow, will be equal to VP, which is equal to RW, and sin theta, which is equal to which is equal to radical, writing here radical 1 minus cos square theta. Okay, I hope till that it is clear to you guys. Now this is the velocity of shadow. Further on, we know that cos theta is equal to, we can say, in the circular motion, the x was, we can say, arc length, and r was the radius, so it will be equal to x upon r. Okay, so let's put this. VQ is equal to RW radical 1 minus r over, oh sorry, x over r whole square. Fine, I hope till that it is clear. Further, we should go VQ is equal to R, we can say omega. Now let's open this. This will be what? This will be R square. Multiply over here and x square divided by R square. Okay, now here it will be what? Cancel. Here we can say R square is cancelled with this radical. Okay, still one R is remaining. One R is cancelled with this radical. We can say shadow velocity RW radical R square minus X square over single R, because one R was cancelled with this radical. Now the single R is cancelled with this R. Now the, we can say, formula of this tangential velocity is made, which is VQ, which is equal to, we can say, omega radical, we can say, x r square minus x square. Wait a second. R square minus x square. Okay. So now this is the formula of tangential velocity. Again, we have learned that x here will denote with the x naught. So x is equal to x naught. So we'll put VQ is equal to W upon R square minus x naught square. Okay, so now this is what this is, we can say, this is the tangential velocity of the shadow. Okay, so now here we will find out the maximum velocity and minimum velocity. So let's have a look. Okay, so here we have maximum velocity. So you know that maximum velocity will be at mean position. The velocity is what? The velocity is maximum at mean position. The velocity is maximum. So here x is denoted as 0 because at, okay, mean position x is 0. So we can say it will be VQ is equal to omega, we can say r square minus o square 0 square. It will be V square is equal to W x naught. Now this is what? This is the maximum velocity. Now let's find out the minimum velocity. Minimum velocity. So here at the extreme position, you know that velocity is minimum. At the extreme position, velocity is minimum. So here x will be equal to x naught at the extreme position. So it will be VQ is equal to omega x square minus x naught square. Okay, and it will be VQ is equal to X square will be cancelled by the radical. Both will be cancelled. Now the remaining it will be 0 multiplied by omega will be 0. So here the minimum velocity of the shadow is 0. So I hope this maximum and minimum velocity is clear. Let me give you one more concept over here. Yep, here we go with it. Remember, at the mean position the velocity is maximum. The velocity is maximum, and at the we can say extreme position the velocity is minimum. Okay, so I hope this is clear to you guys. In the next video we're gonna discuss about the acceleration in the uniform circular motion. Till that, bye bye.